Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video is part 2 of a 2-video pair. Part 1 explained general concepts and principles of control charts. This Part 2 video describes several different kinds of control charts and which to use when. Here are the 5 keys to understanding from Part 1. You can pause the video here if you'd like to review them. Now this Part 2 video will focus on the content of key number 4. It says, control charts show variation in a time sequence from left to right. Control charts tell us whether the variation is within the prescribed range for common cause variation. Run rules define whether the variation is random or whether there is a pattern, which is also visible on a control chart. There are several different types of control charts. This Part 2 video will focus on the characteristics of several different types of charts and which to use when. Normally, our keys to understanding are 1 or 2 sentence statements. Here we're using tables, which are a better way to summarize which to use when. You can see from tables 1 and 2 that the first thing we need to do is determine the type of data which we have. There are 2 types, continuous data and count data. Count is also known as discrete data. It is easy to define. They are always integers starting with 0, that is 0, 1, 2, 3, etc. Count data tells us how many. On the other hand, continuous data, which is also known as measurement data, can have an infinite number of values between any 2 integers. Examples of continuous or measurement data are 0.9, 1.15, 1.8, and 3.14592. Key number 3 gives us some run rules which can identify non-random patterns of variation. These indicate there is some factor which is outside of the process which is affecting the process. Let's start with continuous data. For continuous data, we want both the variation and the central tendency of our process to be under control. Variation is usually measured by the standard deviation, and central tendency is measured by the mean. So we should look at a control chart for each. That is why software often produces them in pairs, as shown in the far right column of this table. For continuous data, we need to collect the data in 25 or more rational subgroups. That is explained in the Part 1 article. In each of the subgroups with n greater than or equal to 4. Use the S chart first to determine if variation is under control. If it is not under control, there's no need to bother with the X bar chart. And use the X bar chart to determine if the central tendency is under control. And use the X, also known as the individuals chart, also known as the I chart, to test for non-random run rule patterns. If the software for these charts doesn't automatically provide that information, and usually it does, also use it to identify individual out-of-control points. If we have sufficient time, money, and opportunity, the best approach is to use the rational subgroup type of sample. This is described in the Part 1 article. Each subgroup has the same size. The minimum size is n equals 4, although more is better. In a rational subgroup, the individual data points are collected close together in time under essentially the same conditions. And we need at least 25 such rational subgroups to show variation over time. Software usually shows these 2 control charts together with the X bar, also known as averages chart, on top and the S chart below. Unfortunately, this can lead the user to consider the X bar chart first. The problem is that the control limits, the UCL, upper control limits, and LCL, lower control limit, shown on the X bar chart are calculated using a statistics which measures variation, the range. If the variation is out of control, the control limits on the X-bar chart will be meaningless. So examine the S chart first. If it is out of control, the process is out of control. As we explain in the book, article, and in the video, which is titled Variation/Variability/Dispersion/Spread, range is an inferior measure of variation compared with standard deviation. For sample size n equals 2, there is not much difference between the two, but as n increases, the standard deviation provides more and more accuracy. By the time n is greater than 9, the difference in accuracy is generally deemed to be intolerable. That is why the R chart can be used for sample sizes n 2 to 9, but for any size larger than 2, it's better to use the S chart. If n equals 1, we cannot calculate any kind of statistic within each sample, but we can calculate a range for two adjacent data points. This is called a moving range, MR. Often paired with the MR chart is the X chart, also known as the individual's chart or the I chart. This chart plots the individual data points, which are the X's. If the data are normal, we don't need to use means in the central limit theorem in order to know that 99.7% of the data should lie within 3 standard deviations of the mean. We can just use the raw data as in the X chart. The X chart may seem less sophisticated than an X bar or S charts, but it has the advantage of showing us the raw data. This enables us to see individual points beyond the control limits, and that can be helpful in investigating the causes of variation. So, many practitioners always include it in their assessments. If the data are not normal and the sample size is 1, we cannot calculate 3 sigma upper and lower control limits, so we don't have a control chart. What's left is an X chart without control charts. This is called a run chart. It's not a control chart, but it can be used for checking at least a few of the run rules. See the Part 1 article, which identify non-random patterns of variation. These patterns also indicate an out-of-control process. Discrete data are integers such as counts. Counts are non-negative. In contrast to continuous data, there are no intermediate values between consecutive integer values. For discrete data, the first criterion in selecting a control chart is the type of thing counted. Are we counting units or are we counting occurrences? What's the difference? Well, let's say we're counting defects in a process which manufactures shirts. The shirt is the unit, and the number of defects is the number of occurrences. Any one shirt could have 0 defects, or 1 defect, or several defects. It is useful to know both how many shirts are defective as well as how many defects have occurred. For example, if we're counting defects, one shirt with 3 defects would count as 1 defective shirt. However, if we're counting occurrences, the same shirt with 3 defects would count as 3 defects. The reason there are 2 different sets of discrete data and control charts is that, you don't really need to know this, but just FYI, they are based on 2 different discrete distributions. The binomial distribution, which is used for units, and the Poisson distribution, which is used for occurrences. For units, use the N, P, and the P charts. The statistic plotted is the proportion of units with defects. If the samples are all the same size, use the NP chart. Otherwise, use the P chart. For occurrences, use a C, the count chart, if the samples are all the same size. Otherwise, use the U chart. Run rules define patterns which indicate the variation is not random, and non-random patterns of variation can be found with the following charts. X bar, X for normal data, NP chart, or C charts. Here are some non-random type patterns. A trend is 6 or more consecutively increasing data points, or 6 or more consecutively decreasing data points. A shift in the mean is indicated by 8 or more consecutive points on the same side of the center line. A cycle could be one of 3 things: 14 or more consecutive points alternating up and down, or 2 out of 3 points beyond 2 standard deviations and on the same side of the center line, or 4 out of 5 points beyond 1 standard deviation and on the same side of the center line. And finally, a line pattern would be 15 or more consecutive points within 1 standard deviation of the center line. And that's it for this video. If you liked this video, please remember to press the thumbs up like button on your screen below. I've made 69 videos on individual concepts in the book, and there's only a few more to do. Please subscribe to this channel if you want to be notified when new videos are uploaded. Also, the website statisticsfroma2z.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website or check out any bookstore. Wiley is the publisher. You might take a look at my blog, statisticsfroma2z.com/blog. I started this when the book was first published in 2016, and I've got some things there that hopefully you will find interesting, like a statistics tip series, as well as posts showing that you are not alone if you're confused by statistics. I've also posted on the Facebook page, Statistics from A to Z, and Twitter as @StatsA to Z.